Good morning, students. Today we are going to discuss the second case of PI, the particular integral of a linear non-homogeneous differential equation with constant coefficients. So let us take the right hand side of the equation as q is equal to sine of ax plus b or cos of ax plus b. Okay. So now since derivative of sine of ax plus b is equal to a into cos of ax plus b, d square, that is second derivative of sine of ax plus b, is equal to minus a square into sine of ax plus b. So we continue with the differentiation, that is d cube of sine of ax plus b is equal to, what is that, minus a cube into cos of ax plus b, and if we differentiate one more time we get a power 4 derivative of cos is sine of ax plus b into a, that a I have written as a cube here, and this a power 4 you can write it as minus a square to the power square, okay, into sine of ax plus b, okay. And if you observe the second derivative and the fourth derivative terms, we can conclude one point. So what is that point? We write in general d square to the power of n of sine of ax plus b is equal to minus a square power n of sine of ax plus b, okay. So from this we can write f of d square of sine of ax plus b is equal to f of minus a square into sine of ax plus b. So by rearranging the terms we are going to get 1 by f of d square of sine of ax plus b is equal to, okay, 1 by f of minus a square into sine of ax plus b. This is what we are going to get, okay. So provided f of minus a square not equal to 0, we need to mention it. So provided f of minus a square not equal to 0, okay. Suppose if f of minus a square equal to 0, then what we need to do? Then we call this as the case of failure, and to overcome this we have to multiply the numerator by the independent variable. Here the independent variable is x, okay, and differentiate the denominator with respect to d, okay. And again we continue with the same process, sine of x plus b, and then we have to replace all d square by minus a square, and we need to write, and we need to operate with sine of x plus b, okay. So fine. So this continues in this manner. Suppose here also, as we discussed in case 1, if f dash of minus a square not equal to 0, then it's fine. and if it is equal to 0, then we have to repeat the above process. Okay, so here also we write f dash of minus a square not equal to 0. If f dash of minus a square equal to 0, continue with the above process. Continue with the above process. Okay, so now after this we are going to discuss the case 3. Okay, so let us continue with case 3.